So I'm Neil Cagney. I'm the director of admissions here, and I teach all first years, but particularly the aerospace. So these are some of the facilities we use. These are the smaller wind tunnels that we mainly use during your first year. So we've got various things for measuring the wind speed or the pressure over wings. We've got smoke visualization tunnels. We have a replica of a cockpit, which you'll use in your second year module for understanding the control and the autopilot for commercial flight systems. Down here, if you can look down, there's some of the larger wind tunnels testing here. So this large is the yellow wind tunnel. You can only see about a half of it, and then it loops underground as well again. That goes up to speeds of about 40 meters per second, or roughly 100 miles an hour. This is the flight simulator we have within the Aerospace Lab. So it's on hydraulic systems, which allows, and the student can sit inside in the cockpit, and with these kind of computing facilities, it replicates the experience of being in an actual flight. We have actually commissioned a larger one to be made. So hopefully if you join us by the end of your first year, we'll have a new, even larger capacity system.
So I'm Babatunde Aramide, and I'm the teaching lab manager for SEMS. And this is G27. It's our teaching lab where most of our laboratory works for the teaching, both undergraduate and some of the postgraduate thoughts programs happen.
I'm Dr. Christopher Chapman, and we're here in the Nanobiomaterials Laboratory, and this is specifically my bay, where I do chemical synthesis of conductive polymers and make them into usable bits to put inside the body. We're here in the undergraduate mechanical testing laboratory now, and just wanted to show one of the Instron machines that we use in the undergraduate teaching. These machines take different materials and apply force and then pull them apart. As you can see, they're quite tall. In this laboratory, we have 6 different machines that you can have access to and use for your different design projects. We're in now the undergraduate wet chemistry teaching laboratory, and in this we have a bank of 3D printers that we use for undergraduate teaching. And these printers, you can create 3-dimensional models from a vat of liquid resin that's photopolymerized. And we also have fused deposition modeling printers, which actually print a plastic filament directly into a 3-dimensional object. Here we have 2 of our 4 wet chemistry teaching lab fume cupboards. We have all the way on the other side of the lab the other 2. And yeah, as you can see, it's a very big laboratory.
Hi everybody, welcome to Queen Mary Makerspace. My name is James, I'm the Makerspace technician. So prospective first year undergraduates, if you have any kind of practical artifact that you need to make, then this is the student workshop. We've got lots of selection of hand tools available. And if you look behind me as well, we've got large open plan benches. So as you can see, fully equipped 3D print farm as well in terms of FDM technology for rapid prototyping. We also have SLA based printing as well with lots of different engineering grade materials. We're also fully equipped to support electronics, as well as if you look behind me, you can see we also have a desktop water jet cutter for processing composites and metal based materials. In addition to all the equipment I've just shown you, you'll have full access to technical support from myself and the rest of the team here in the Makerspace. So if you have any questions about how to produce something or you're not quite sure, we're always here to help.
I'm Dr. Karen Shoup. I'm the Program Director of Design, Innovation and Creative Engineering. And this is our space. This is the design studio. This is arranged by the students. It goes through different formations depending on the sessions. We have presentations here. The focus is mainly on coming up with the ideas, all the rough sketching, prototyping, very basic mock-ups happen here. And then quite often they become bigger and we move to the Makerspace, which is just across the corridor, where you can do the wood tools and so forth. This is so that they can take proper photographs. So we have proper lighting and we have different white and grey backdrops.
Hello, my name is Caspar Althöfer. I'm the director of the Center for Advanced Robotics at Queen Mary, and I'm also a professor of robotics engineering. In our robotics lab, we carry out quite a bit of research that is linked to industry, and we have projects with the nuclear industry in particular. Here we are interested in creating robots that can go into remote environments because they are radioactive. You cannot send humans there. We can see here a system that is a prosthetic device, so for people who lost their arms, or were born without arms. That device could be a useful system to be used by amputees. And so it is made from silicon rubber, so it's very soft, very flexible, and it has now air chambers integrated, which you can see here in black. And when we actuate them, I put pressure in them, then they the fingers start moving, and we can use them, as a robotic hand.
I'm Anastasia, and today I'll be giving you a tour of G25, the headquarters of Queen Mary Formalist Student Society. So starting off, I'm going to introduce you to what we call Composites Corner. And this is our area where our composites team work on creating the bodywork and aerodynamic components for our competitor. You can see our mock chassis, which we've been preparing for our competition at the Formalist Student Competition at Silverstone this year. This is the main area we manufacture our competitor year on year. This year we are competing at Silverstone for the 8th year running, and this is our car, Ashling. This year we aim to improve on our dynamic and static event results from last year's, where we positioned 26th out of 88 competitors.